You want to start building some electronics. It could be a gaming console, cool robots, or home automation. And the biggest problem, you don't know even how to start, because your dream project contains dozen components, require a lot of code and knowledge you lack of. So if I guess right, give me a few minutes and I'll promise to help you. Hi, I'm a software engineer with over a decade of experience. And the biggest thing I learned, you need to practice. And before you leave thinking it's obvious, ask yourself how many times you watched a video about building some project and then actually build it. I have a solution. Let's learn together different aspects of building electronic devices, from simple ones like using button or control LED to more complex. For every component, I'll show you a project you can easily replicate with a new knowledge. In this video, I'll explain you why I choose ESP32, how it interacts with the world, and what tools and hardware you need for practical lessons. We will set up our environment for coding and write our first program. Also, I'll show you one awesome feature you probably never heard of. As a microcontroller, I'll be using ESP32. There are a lot of different versions, each with its own pros and cons, and over time you will know which one works best for you. But for now, I recommend use this one, ESP32 Dev module, which makes prototyping so easy. I won't provide you full list of features because it takes too long, but here is my best. It has inbuilt Wi-Fi and Bluetooth, really useful digital to analog converters to connect, for example, speakers. It supports common interfaces like SPI, I2C, UART, and here is definitely not the full list of advantages. Last but not least, you can buy ESP under $3. To move forward, you need to understand how ESP interacts with the world, meaning hardware, sensors, and components. Yeah, I know, it's kinda boring stuff, but it's really important, so let's break it down with some simple examples. If you connect a button to one ESP pin, pressing the button will change the pin voltage to either 0 or 3.3 volt. The controller can read this voltage and convert it to logical 0 or 1, allowing you to make a decision in your code. Beyond simple on-off detection, the ESP can also measure exact voltage levels. Instead of just 0 or 1, an analog pin can detect one of 4096 possible values, which is extremely useful when working to sensor. For outputs, the same principle applies. You can set pin to 0 volt low or 3.3 volt high. But in most cases, communication with other components goes beyond simple high and low signals. More advanced protocols like PWM, I2C, SPI come into play, but they are all built upon these fundamental principles. The only required stuff you should have is USB cable to be able to connect ESP to the computer, and USB type depends only on the interface you have on ESP board and a computer. Just make sure your cable actually supports data transfer. However, I strongly recommend you to have at least breadboard and jumping wires for easy prototyping, bunch of buttons and switches, basic electronic components like LED, resistor, capacitors, transistors, etc. Power inputs for 5 volt. You can choose higher voltage input, but in this case you also need a DC-DC converter to reduce it to 5 volt output. Speaking about tools, you actually don't need any of them while prototyping, but nice to have a multimeter for measuring voltage, current and detecting short circuits, soldering tool, cutting tool, wires and soldering breadboards for more advanced projects. Finally, we are ready for practice. At first, we will set up the environment, and basically you have two options, Arduino IDE or VS Code with Platform I/O. Both of them totally free, but VS Code makes your life simpler. You don't need to memorize tons of functions because it has autocomplete. You can easily debug your program line by line or ask Copilot to write code for you. Use GitHub and many other features good IDE should have. I will use Platform I/O in VS Code, so to install it, everything you need, navigate to code.visualstudio.com website and click download button. You'll get the installer depends on your operational system. For macOS, I'll just move downloaded file into applications. For Windows, you need to follow installer instructions. After installation, we run VS Code and find Platform I/O extension and click install. It takes some time to add all core dependencies, but it shouldn't take too long. Once it's done, a new button will appear in the left panel. Click on it and select Create New Project. This should take you to Platform.io homepage, where we press New Project. Let's choose a name and board. As I suggested before, I'm using the ESP32 dev module, so I select it from drop-down. We are okay with the Arduino framework, so leave it as it is. Finally, you need to specify the project location. I'm fine with default one, but feel free to change it if you prefer. After pressing finish, we need to wait a few minutes, and don't worry, it only takes a long time the first time. If you did everything right, a new window with our project should open automatically. The very first file you see is platform.io.ini. The file we are currently interested in located in src folder. Open the main.cpp file. Let's delete demo function and break down all imported code. The first line include arduino.h allow us to use Arduino SDK in our application. Actually, it contains all core functions which makes programming ESP and Arduino so easy. As you can see in the comment, the setup function runs once. Inside, we configure our application starting point, such as defining modes for pins or starting Wi-Fi access point. The loop function runs repeatedly, as fast as possible while ESP remains powered on. Let's write our first simple program, blinking LED. And because I don't expect you already have any electronics, we will use the inbuilt one. Let's check the board pinout reference. As you can see, the pin labeled as D2 connected to onboard LED. So in code, I'm defining the constant with meaningful name to make our code readable. The value is equivalent to GPIO we seen in our reference web page. Next, we should set pin mode to output, because we want to control it, but not read the data. To turn on or off LED, we need to send high or low signal to that pin. It could be done with a digital write command. So, if we want to make LED blinks, place both commands one by one. But here's a problem. We have no pauses, and current code will repeatedly run million times per second. So let's add 1 second delay after each command. Congrats, we complete our first very simple program, but how to upload it to ESP? First, we need to build project. It's kind of translation program from human readable text to machine code. It could be done by pressing this teeny checkmark in the bottom panel. If everything correct, you'll see success message. If you made a mistake, the compiler shows you the line with the error. After compilation, plug in ESP and press arrow in bottom menu. It should upload the code directly to ESP, and if you have any problem with this step, don't be shy and ask in the comments. But what's the cool feature I told you before? Actually, most of ESP boards have inbuilt touch sensors. These are capacitive pads that can react to any conductive elements, like human skin. So basically, you have 10 free buttons you can use in ESP projects. So let's define GPIO4 as a touch sensor using a constant. The touch read function allows us to measure capacitance and make decisions based on it. Let's turn on LED when the sensor is touched. But what's the magic number 20? At first, we should enable serial monitor. It's kinda system log, which is incredibly helpful during debug. It could be done by adding serial.begin in setup function. To print something, we need to call serial printline function. Lastly, we'd add monitor speed in config file, which should match the number in setup function. Upload the sketch, and to enable monitor, navigate platform.io icon in left panel and select monitor. Keep in mind that ESP should be plugged in to the computer. As you can see, when nothing touches the pad, the output value is high, but once I touch it with finger or piece of wire, the value drops. However, it's not a constant, so I choose 20 as a threshold to make it work with different materials. That's it for today. In next video, we will learn how to use inbuilt Wi-Fi feature, how to interact with the buttons and write our first simple game. Let me know in the comments what do you think about such format, and thanks for watching.